Okay, so looking at the robot construction rules, um, largely these don't change too much year to year. At this point in FRC, we kind of just iterate on them and tweak them a little bit year to year. There's some things that they've already announced are coming. But starting last year, they added in evergreen rules. So it's a little bit weird because like these things, this whole like long paragraph lists up here are part of the rule book, but are not rules because they're not like numbered. But they are rules because they're in the rule book, but they're also not. So it's very confusing as to what these are. Um, they're kind of like explanations for the rules, but they do kind of count in certain areas where they are important. So they define certain things. So anywhere where they use the term COTS, that's commercial off the shelf. It basically just means anything you can purchase directly. You don't have to like make out of raw material. This kind of defines some of the things that we call a vendor and some of what those are. It's a whole thing about what a vendor is. There's a bunch of arguments about what this is and how these exist and what they go into. Most of these don't matter. If you can buy it or if you had been able to buy it, most of the time it's legal. And for all of the stuff we have, it's all legal. Fabricated items are things that we've built, but also things that have been altered. There's also stuff that can be in between a little bit, which is kind of odd. Which is what that blue box says. So basically, it's possible for an item to not be COTS, but also not be fabricated. So if you have bought like a big sheet of plywood, right? It's a full 4x8 sheet of plywood. That's COTS because that's in the exact form you got it, right? If you then cut that piece of plywood in half to make it easier to store in your lab, it's no longer COTS, but it's also not fabricated. It's in between. So basically what it means is that to be fabricated, you had to like have assisted you in getting it to the form it's going to be on the robot and has like some sort of usefulness of being changed in that way. There's a bunch of reasons why this matters. It comes up every once in a while. Most of the time, this won't affect anything you're doing. If you do, just ask me and we'll figure out what it is. Because this is a really weird part of the rulebook that not a lot of people understand fully. Things that are important. So all of these green rules, so like R101, this rule is probably going to be the exact same as the rule in 2023. Like, it is very likely that any of these ones in green are written out and going to be worded and everything are going to probably be very close to identical. So we can actually already start seeing some of the stuff that's going to be in the 2023 rulebook already. So frame perimeter must be fixed. What that means is you can't have, like, if we had like the rectangle that makes up our robot, we can't have like pivots in it or like ways that it can like flex and move around and do weird rocky things. It needs to actually like the corner and the corner need to roughly stay the same dimension from each other, and they shouldn't just be able to like fold in on each other on purpose. This gets a little weird because every once in a while teams will try to make like suspension drives and stuff where the thing that becomes the frame perimeter ends up wanting to move up and down or wiggle, and that ends up being illegal and not good. Because then you could in theory change your whole size of your robot and stuff, and it would just be really weird if this wasn't a rule. The implications of what the robots could be are very, very odd, and it would just be very hard to standardize and like actually inspect robots. So they make this a rule. We've never broke this. We probably won't. Our frame almost certainly is just going to be for swerve modules with 2x1s connecting them, or something along those lines. Okay, so yeah, so this is also where you kind of define that you have a frame perimeter. You are allowed minor protrusions, so bolt heads, things that are less than about quarter inch, or no greater than quarter inch is what you're allowed to have. So you can put a socket head bolt can stick out and not be part of your frame perimeter. um, rivets, that sort of thing. Um, but if you end up having like a whole plate or something, that normally doesn't work. Okay, so starting configuration is how you actually start when you set the robot on the field. Um, Basically, this part of the rulebook says that you can't have a mushroom robot, right? Like the frame perimeter down at the bottom that gets wrapped by your bumpers needs to be the farthest thing to the outside of your robot when it's in its starting configuration. So you can't have like a tiny little frame with bumpers on it and then go up and get bigger when you're higher up, right? Um, that's not allowed. So the part that gets wrapped by your bumpers has to be the biggest part of your robot or the same size all the way up. Which makes a lot of sense. The bumpers are there, so they're the first piece of thing that gets contacted. If you were allowed to have like a mushroom robot, you could run into a wall and like your actual robot would hit and not the bumpers, and that just wouldn't work well for a lot of things. And just like keeping the design the way we want them and everything like that.
What about the intake?
So that's not in starting configuration, right? So you're allowed to extend once the match starts, but when the match actually starts and when you're inspected and everything and you're in your starting configuration, it all has to be inside your frame perimeter.
So later you can become a mushroom?
Later, yes. Some games you can't. Like there have been games in the past where you were never allowed to extend at all. So like you were whatever your starting configuration is, that's as much as you're ever allowed to extend out. Um, we haven't seen that in a while. My guess is you'll be allowed to extend again in most games, but it's possible we get rid of frame extensions or we get rid of perimeter extensions at some point.
Wouldn't that mean that like you can't use an intake?
Well, you couldn't use an over the bumper intake.
Oh, so you have to like build it into the bumper or something?
Yeah, or like the game piece could be bigger than the bumper. So like if it was a 2014 ball, right? Like the game piece is just bigger than the bumper.
Okay.
Yeah, starting configuration, weight limit. Robot cannot exceed 125 pounds. That does not include the bumpers or the battery and its connector. And there's a special caveat now in C, which are the zebra tag system, which I think we used. It was there at Texas, but I don't think we actually ever put them on our robot. It's Texas State Champs. But if those tags exist, those don't count to your weight either. So yeah, so we're allowed to build up to 125 pounds. Normally, we're going to try to be quite a bit lighter. Like as we're going through things, we try to design closer to 100, end up being at like 115, 118, and so that we're never pushing the limit. Like one of the worst days you can have in FRC is getting to an event, putting the robot on the scale, and it coming back at like 127, and you trying to figure out how to pull 2 pounds off your robot is not fun. Like it is one of the worst things. It used to happen a lot more. It's pretty hard to do that now. Like one, we have scales, and also we just build lighter robots now. Motors are a lot lighter. Gearboxes are lighter. In general, just robot parts in general are now a lot lighter than they used to be. There used to be a lot more steel on the robot. Now it's mostly all aluminum. So it's a lot easier to be lightweight nowadays than it was back then. And they made the robot weight limit slightly bigger. We used to be 120 pounds. They added 5 pounds 3 years ago, whatever. COVID got weird. 2020. They added 5 pounds. So it's even easier to stay under now. So we have not been over in a long time.
When you want to be like pushing the limits so that way like you can't get pushed around by other robots?
If we cared about that, yes. So there's two different philosophies on how you think about weight limit, right? So if you're worried about maximizing traction maximizing traction on the ground, friction on the ground, yes, you want your weight to be the highest, so you have the highest normal force, and you're pushing harder. Once you're into swerve, you don't really care because swerve largely loses pushing battles anyway. The main reason being the wheels aren't all connected, right? So if you get into a real pushing match with a well-designed tank drive, almost certainly where your contact point is when you go to push up, when like your two bumpers hit, some of your weight transfer is going to get lifted off your front wheels. Once that happens, you lose that percentage of motor power in the pushing battle, right? Like it's no longer being useful because you're not putting that quarter of your weight down on those two wheels anymore. They're going to some of that weight's on your back wheels, some of that's transferred to the other robot. But either way, once some of that's off the ground, you no longer have like 4 Falcons actually pushing your robot. And the tank drive robot almost certainly does because all of their wheels are chained together. So if they're only on their back wheels, they still have all 4 or 6, however many motors they have driving their drivetrain, pushing them forward. Most of the time, they can also, like, if you're trying to really get a lot of traction, you can have either pneumatic tires or super wide tank tread wheels, or not tank tread wheels, but like treaded wheels. And you can win a pushing battle a lot easier on a 6-wheel drive or 8-wheel drive robot than you can on swerve. So we don't really care trying to push weight. You don't want to be so light that you just get knocked around and you can't like push through somebody a little bit when you need to. Like if you can't actually generate momentum. So if you're going fast and somebody's in your way to where you can like spin them out of the way or something and you have enough momentum to do that, that's still useful. But you don't really want to get into like a standstill pushing battle with swerve robots because you're almost always going to lose. So there's some balance there. Also, if you're too heavy, you also accelerate slower, right? Because it takes longer to get up to speed. So being light means you can travel faster, quicker. You can be more nimble. There's definitely some point where too light is too light. If you're sitting around, like, I probably wouldn't want to compete with an 80-pound robot against a bunch of 120-pound robots. That's probably too light. But anywhere from like 95 to 110 is totally fine. I don't think in most games, it's not going to be a problem if you're around that weight. Once you add bumpers and battery, the percent difference between a fully maxed out weight robot, which now is like what? So you're allowed 125 pounds for robot. Later on in the rules, you'll see that you're allowed 15 pounds for bumpers. So that's already 140. That's about what they weigh. Yeah, I think our bumpers last year were like 13. So you're allowed 15 pounds for bumpers, so you're up to 140. And then your battery assembly is normally around 13 or 14 as well, somewhere in there. So you push 150, 152 if you're fully maxed weight. You knock off 20 pounds of that. If you come in at like 105, you're still 135. That's fine. Like you're not dramatically underweight compared to another team. And you still can move people when you need to, and you're not just going to get completely knocked around or upended or anything like that if you're that light.
If our robot is ever too heavy, would we ever like drill holes into like?
In theory, yes, but in reality, no. So drilling holes gets you very little weight. When we talk about actual weight saving, so we were pushing weight in 2020 when we were trying to build the buddy climb mechanism in. We eventually just scrapped the mechanism, which is the actual way you cut weight. So the easiest way to cut weight by far is just reducing the amount of features on the robot that you have. So if you can just take a whole system out, you're going to lose a lot more weight than if you try to drill holes and everything. All of our material is already designed to be incredibly light. It's all very thin anyway, or as thin as it mostly can be. And the amount of holes it takes to drill out of like any sort of like plastic piece or something to get a pound out, at that point you're like compromising the whole structural integrity of the thing anyway. For us, we're almost certainly not just going to sit there and like hand drill almost ever, because we would just make the part again. So most of the time if we ever come into a thing where we have a weight problem, which sometimes we do, especially like there's specific things that we want to reduce weight on. If we want to like reduce weight high, so we want to like just make a system that is high on the robot lighter, most of the time we're just going to redesign that system entirely to get the weight lower. So we might change the mounting location of motors, change gears and things, or you might have like a system that was gears before, so there's a lot of steel there, and we might swap that over and make it belts and 3D printed pulleys, and that might cut the whole weight of the gearbox or whatever in half, because now instead of using a heavy gearbox, we're using belts and pulleys. So those types of things where you do a full redesign of some mechanism and to be able to reduce weight is better than just drilling holes. So in a good example of that is in 2020, like mid build season, we knew we were going to need to get some weight if we wanted to have this buddy climb thing. Our intake at the time was going to be 3 rollers, and we realized if we made the rollers bigger, we could go to 2 rollers instead, and that reduced quite a bit of weight because like the shafts across, the bearings, the pulleys and belts and everything for that, going to 2 rollers instead of 3 and just like changing their positions a little bit, cut the weight of the system by like almost 2/3 or whatever, because the actual just increasing the size of the polycarb doesn't change the weight much at all. All the rest of the parts of the rollers change the weight a lot. So that's normally what we're going to do, is we're going to do a lot of design changes to get rid of weight, not just drill holes, because it's not really feasible to drill holes most of the time. It's also not fun. Back when you could drill holes to lose weight, when we used to have a lot more steel on the robot, I distinctly remember, I think my senior year of high school, so 2006, we had all of our sprockets were steel, so it's like 1/4-inch plates of steel on each wheel, right? Way more material than are needed there to just run a robot, but aluminum sprockets didn't really exist back then. So I distinctly remember like having the robot on its sides. We didn't want to pull them all off, and like putting the drill press on the floor and just sitting there and like drilling 8 holes into each wheel, and like just like rotating the wheel, drilling the next hole, like with the drill press on the ground, and like sitting there doing it on the robot, because that way you actually did get some amount of weight. But even then, I think all of the holes across all of the sprockets, which were like 16 sprockets on that robot or something or more, was only like 1/2 pound or something, if that. So if there was any other way, we would have much preferred that, because it was not fun. It was like probably 2 hours of just like sitting there drilling holes.
And then if the part breaks, you have to do it all over again.
I mean, you're not breaking a steel sprocket.
Okay. Do you want to build a robot that's more like centered to the ground for the weight, or just like in the middle of the robot?
In general, the lower your center of gravity is towards the ground, the better. It's going to handle a lot better. It's going to be more maneuverable. It's less tippy. It keeps the wheels planted on the ground. That's one of the things we were just. That was one of the problems with our 2022 robot, was as you tried to change direction, if you change direction quickly, 2 of the wheels almost always came off the ground, which means those wheels aren't helping you accelerate in that new direction. So you're less maneuverable because of that. So getting the center of gravity low is rather important if you're going to try to be able to change direction very quickly like you can with swerve. But that means you need to get the center of gravity as low as you can. That's something we did not do a great job of last year that we'll probably try to work on this year. Okay, so back to the rules. We're at 104. Starting configuration, max size. So that's where we talked about frame perimeter earlier, how it exists, but we didn't actually talk about what the number is. Lately, that's stayed 120. At different points in the past, it's been a different number. So I think 2013, it was 112. And it's been 120, I think, most years since then. In general, that's one of the ways we actually keep the robot lighter, as well as we make our frame smaller. So 120-inch frame perimeter means you could build a 30 by 30 robot, and that's exactly 120 frame perimeter, right? If each side is 30 inches, 30 times 4 is 120. And so you could exactly do that if you wanted to. A 30 by 30 robot, if you're used to the ones we've built recently, is a very big robot. Because even like the 8515 last year looks rather large compared to our robot in like its frame. But it's not even full 120. It's short by a decent amount, if I remember correctly. I think it's like 35 by 26 or something. No, that's not right. 33, 32 by 26, something like that. It's relatively narrow, and it's just longer than what we've built recently. The trade-off with frame size is if you build too small. So small is good because it allows you to be light and it allows you to get through smaller gaps in the field, so it's harder to defend you because then you can just go through a smaller space, which is helpful. And so that's why we normally try to be relatively small. If you go too small, it gets harder to stay stable because your wheels just aren't as far apart. So it's easier to like tip over. If you're tall and really small, it's very easy to tip over. Or if your center of gravity is high and you're small, it's easy to tip over. So there's some trade-offs there of being really wide of a nice base of support, make it really hard to tip, but then it's harder to maneuver and it's easier to get heavy if you build everything. If you build that super wide frame, all of your crossbars across the frame and everything have to get a little bit longer, and you just add a little bit more weight by just building your frame bigger. So by building it smaller, you can get a little bit lighter normally, and it's easier to get a little bit more maneuverable through tight spaces, but you don't have as much stability. So there's probably something to be said for being a little bit bigger than we were last year. I think we were 27 by 25, somewhere in there, like 27 and a half by 25 and a half. There's probably something to being a little bit bigger than that, where we're probably hitting closer to 28 by 28, somewhere in there. Especially if we get a robot, or if it's a game that needs some sort of elevator, or anything where your weight's gonna be shifted up high. Like anytime you have to extend really high, some of your weight gets really high. It gets a lot easier to tip over. So building a wider frame for any game where you have to be tall, especially if it's like really tall, we might go the full 30 by 30, or something close to that, 29 and a half by 29 and a half.
Would that be like a 2018 game?
Yeah, something like that, 18 or 19. It's very possible we go pretty large. It doesn't have to be square. Square is somewhat helpful in Swerve in that your dynamic, your like acceleration should be similar. Like how much you can rock if you accelerate in any orientation is going to be similar. But we built rectangles Swerve the last 2 years, 2021 and 2022 were both rectangles, and they're fine. Like the control system works completely fine with that. It's just whether the dynamics of how it can rock are a little bit more, right? It was easier. Our robot last year could flip accelerating sideways easier than it could forward and backwards because it was just shorter on that wheelbase. Okay, so yeah, so this is the extension limit that we were discussing earlier, Rebecca. So in each game, we have a different extension limit. So this past season, it was you couldn't extend past the frame perimeter 16 inches. So it does kind of curve in the corners, right? It's not like it doesn't make your box 16 inches in both directions. It actually is a corner curve and stuff. So it gets a little bit weird if you're trying to extend past your corners. You have to be careful. Yeah, this is checked at inspection, and we check in CAD and stuff. We extended pretty small last year compared to most teams. I think we only extended 8 or 9 inches past our bumper with the way our roller worked and stuff, so that we didn't have to extend as far. This definitely gets interesting with like the penalty rules and stuff. Last year we saw a lot of teams getting penalties for running their intakes into other teams, right? If you extend outside of your frame perimeter and then you damage another robot, that can cause problems. So there is some advantages to not extending as far and figuring out how to do things in your frame perimeter, so you less risk of damaging other teams, also less risk of having those things, whatever your extensions are, getting run into or getting broken.
Would that be like how 118 had the issue where they accidentally disabled robots?
Yeah, so like that one time they did it to us, yeah, they ran into, their intake stayed out, they ran into us, even though it was like a bang play on who initiated or how that works. The rule itself doesn't even allow for like initiation. It literally just says if you're extended out, doesn't matter who initiates the contact. If you're the one extended and you damage, it's still on you. My guess is that rule gets tweaked a little bit, hopefully this season, and is not worded the exact same as last year, because it did lead to some very bad situations. Like, it's very awkward when we're like, hey, we don't want you to be penalized. We think that was our fault too. Like, but then the refs still have to call it the way the rule book words it. So yeah, so if the rule doesn't change, that leads us to having a lot more conversation about what our intake looks like, or any extension past the frame perimeter. And do we not do that? Do we have a bumper cutout instead? Or do we have a bumper cutout plus a very small extension intake that doesn't pass the other team's bumpers? Something similar to like some of the Mechanum intakes that were really, really narrow, or short, so they just extended a few inches past the bumper, if at all. Yeah, Kryptonite was close. I think Rembrandt's did something like that, where it was much harder for them to run into people frame than even ours or 118s or anybody like that.
Are we gonna Q&A the rule if they don't change it?
I mean, there's not much to Q&A. Like, the wording is what the wording is. If they don't change it, we know how they're going to call it because they called it last year. Yeah, so we got some more green rules. So these are all going to be the same as last year. These are mostly just the safety and damage stuff. These get this, especially 201, is very interesting, as what this means and how it's interpreted is very odd. But basically, it means if you begin to damage the carpet, they can tell you can't use the wheels. There's certain things you absolutely can't do. So we know you can't. You can't use Velcro directly. And you can't have other things that are directly attached to the carpet anymore. You can't use like sandpaper. The main reason this rule exists is from like back a long time ago in 2002, the Beast 71 had a drivetrain that used file cards, which basically like adhered them to the carpet, like you could not move them. But they could like move the whole field if they wanted to, like they had that much traction. And they literally like shuffled along the ground, like they had these little things they picked up and put down. Yeah, but I mean, because you couldn't move them, it was ridiculous. So it made sense to eliminate that, and there's a bunch of other things. You can't have hard plastic studs, quote unquote, which what that actually means, no one quite knows. Like it's very odd, right? Things that are for sure legal are like the tread that we use, even though it does kind of grab and interface with the carpet. It doesn't do it in a way that people believe damage it. So really, as long as you're not ripping the carpet up and damaging the carpet in different ways, you're normally okay. But it is something that we can, that the inspectors can rule you illegal on. So there's some fine line there on how this rule gets interpreted. What else? Yeah, no sharp edges, so we just have to make sure we fillet all of our corners when we make parts. This is really important, so when we send it to the laser, we don't just have these nice sharp pieces of plastic anymore on the router. We don't have sharp pieces of metal. So make sure all the corners of all of our flat parts get rounded. And then if anything does come out sharp, we have to sit there and like file it or deburr it and make sure it's not sharp. 203 is the rule that basically says you can't make dangerous things, don't have sirens, things that are really loud. That it's robots are allowed to make noise, because otherwise that'd be a ridiculous rule, right? You can't say robots can't make noise.
Tesla, like when they first came out, like the cars were way too quiet, so they had to like add some kind of.
Yeah, and there still are issues with some electric cars with them being too quiet sometimes. But yeah, so you're just not allowed to have noise in such a way that become a distraction. So it's basically you're allowed to make as much noise as you want until the refs or the field crew tell you you're distracting them, and then you have to turn it off. Is pretty much how that rule actually works.
What about if you're like in the stands, like if you start yelling or something?
That's not the robot. What's happening?
I thought it said like or interfere with the operation of other robots.
What? Yeah, but this is a robot rule, Evan.
It's a robot rule.
It's a robot rule.
Okay.
Yeah, you also can't just build like curtains, so you can't just have a robot that goes and like covers somebody's driver's station.
Or if you like cover a lamplight or something.
Can you like?
No, that's different. That gets weirder.
So I think I saw a robot with like lights on it. Is there like something like they can't be too bright?
Yeah, there are some visual stuff, um, which comes in here. Yeah, so high intensity light sources used on the robot. This rule is also another very complicated and subjective thing. Um, yeah, basically you can't have like military grade or self defense things for sure. Things that like clearly are designed to like temporarily blind people. Um, but where that falls in the line of like what a limelight is and some other things gets really weird. People like whether they have to be like momentary. It's very odd. Some of it's based on like what angle they're at. But like there are certain things you definitely can't do. If you walked out, if like again, if, instead of having a big curtain that you put in front of a driver's station, if you just shined a very bright light directly into like driver's eyes, that's clearly not legal. Um, like in general, part of this rule is don't do things that damage or affect the other drivers or the other robots or the field itself. Um, right, so you can't have like liquid mercury. You can't have uncovered lead. You're allowed to have lead. You just can't have uncovered lead.
Why would you have lead though?
It's very dense. So if you need a very dense weight, it's very dense. Um, you can have ballast, but you have to have it secured in a way that it's not going to spread on the field. There's a lot of weird intricacies of this and like how they get done, but people have tried lots of things. You absolutely cannot just put like a bunch of like BBs in a canister or something, because then if those go all over the field, it'd be super annoying. You can't have sand. Sand anywhere near the field is awful. So yeah, like what you're able to do and what you can't is a little bit odd, but as long as you're taking precautions and you understand that you're trying to not damage the field, you can normally be okay. Um, Most of the time, a big steel plate or an actual like dumbbell is better anyway. Um, yeah, no hydraulic fluid or any fluids, pretty much, other than like any liquids. Sorry, gas is a fluid.
So you can't use hydraulics.
Correct. There are no hydraulics are ever allowed. Nothing flammable. Lasers that are anything other than class 1 and class 1 lasers are normally not visible, pretty much never visible, and are very low powered. So there's certain things you're allowed to use them for, like certain laser sensors and stuff are class 1 and are okay, but they're not. They're not like any laser pointer or anything like that. All of those are illegal. Yeah, basically 204 is robots have to make sure they can remove the game objects. You can't just hold the game object forever and not be able to remove them without power. And then don't have anything get on the field. So you can't have lubrication that gets on the field and damage the field in any way. Okay, 9.3 is all the budget stuff. This gets into a bunch of really weird details that, again, most people don't need to understand. The main thing is no single part that we buy for the robot can cost more than $600.
Is that like so that you buy actual parts and not like buy a whole robot?
Yeah, that's largely what it ends up being. It also is just somewhat to make things fair. Like there are like specialty sensors and stuff that exist that are $3,000-$4,000. They're designed to be on military robots and things. They don't actually give you a big advantage if somebody were to use them. There's some other things that you can't use because they could cost that much. Zipper masks come to mind. There's some like specific mechanical parts and things that are incredibly expensive that would be cool, but we just don't want to have that as part of like the arms race in FRC of like building a better robot, because you have to spend $2 or $3 grand on a single part.
Is this what, whenever we were talking about 2015, you were saying like the beginning where you had to like, people were spending like so much money on like.
Well, 2015, they were spending all that money, but that was not individual parts. That was just like raw material and just being able to. That was just development costs. So like they were just buying a lot of stuff and expensive stuff, but every individual piece was under $600. Yeah, so there's a bunch of rules that go into how to actually do that cost accounting and what all that means, and how you define what a single part is and what it isn't. It's a whole thing. It's not a big deal. 302 is the rule that basically says most of what you have to build, most of what goes on the robot has to be built that season. Certain things can be built whenever, so like operator console, that's why we're building ours now. Bumpers can be built whenever, but most of the time we're going to build them after we know what our robot's going to look like. Battery assemblies definitely don't have to be built that year. That'd be really annoying if you had to rewire our batteries every year. And then there's a couple new things that got added recently, and there's a new one even newer for 2023, that basically says D was added a while ago, which is very useful, in which fabricated items, if you have a single COTS electrical part, so a motor controller, or any electronic device that we buy, you're allowed to modify the wires on it. You're allowed to add connectors to it. We're allowed to modify motor shafts, and gears or pulleys can be added. So like if we have a Falcon that already has a pinion mounted to it, or if we have a motor that already has a pinion mounted on it, we're allowed to still use that year to year. We don't have to take it off and put it back on or something. That'd be annoying. There's other reasons why that's allowed now too, but what else? Most of the time for this rule, it's all intent, but also we're designing the full robot from scratch anyway. So rarely is it going to be like, oh yeah, this happened part from 2022 happens to exist again, and for some reason we're using this exact part we made and not making it again anyway. Like, why would we do that? Like, if we needed to, most of the time those can like go on the practice robot, and then we make the new one anyway for the comp robot. So if there's a part that needs to get reused, it ends up on the practice robot first anyway, and then we make it for the real robot.
It's also not in the spirit of like gracious professionalism, right?
Right, we wouldn't do it, but she's saying how do we make sure we don't do it?
Okay. It's like the same thing with like the bag.
Yeah, but most of the time there's no real incentive to, and there's almost no reason to. Like, it's almost always better for us to make a new part anyway, so we're always going to make the new part. Rarely is there some part that happens to be the same, and it would in any way be better to use the old one. The old one has probably been used already, right? Like, it's been damaged in some way, so why would we want to put the damaged part on our comp robot? And things like that. So most of the time we don't. The rules have opened up quite a bit anyway, so this rule exists, but then other rules get stacked on top of this to make it even easier to not violate the rule. So E exists now, so COTS items are allowed to all be reused always, right? So anything that's been on a robot but is still COTS is fine. So if we pull a gear off of some old robot, we're allowed to use it again if it was just purchased, right? But you're also allowed any non-functional decoration or labeling. So if we powder coated something but it's still COTS, that's fine. You're allowed any assembly of COTS items per manufacturer step. So like in reality, we can take an entire swerve module and have it built. And so if we wanted to assemble our swerve modules fully for the 2023 season, we could do that ahead of time. Like, it is possible. It doesn't really benefit us to do it, but we could. And there's no that's all legal. Anything that's a fully COTS device or mechanism that isn't a major mechanism, which is a whole different thing of what isn't a major mechanism, a whole different can of worms to open up. But basically, major mechanism has to like fully solve a game problem. So a single swerve module doesn't do that. We couldn't build the entire drivetrain, but you can build a single module, basically.
Okay. So like, this is only in response to like fabricated items? So you could like CAD part of a robot subsystem like the drivetrain already, assuming you know what frame parameter you want to use, which like most likely you're gonna change it.
No, so using CAD and stuff is a little bit later. That's separate, but you couldn't fabricate anything, right? These are only COTS items.
Okay.
If we actually like laser cut stuff, then you can't use it directly. Kind of, because the new rule is a little bit different. So, and then C is anything you can do to a COTS part that can be reasonably accomplished in fewer than 30 minutes with the use of hand tools. Hand tools include hand power tools. And that rule opens up a lot of things. Because what is reasonable is a whole different thing, and like how you section things is a whole different thing. It's very odd, but largely it means you're allowed to drill holes and stuff, and it's still legal. That's the main gist of what you're right. If you can cut things in half or drill them, and it's all, as long as it was at 1 point COTS, it's all fine. What they added for this coming season is you can also make your own parts as long as they are replicas of COTS parts. So if a COTS plate exists, like so if a COTS gusset exists, right, like the L gussets that we buy, we can reuse those season to season. We can drill holes in those season to season. We can also route our own out of a big sheet of aluminum, and that still counts too because there's a COTS equivalent of that part. We think this also allows us to like reuse 3D printed like hex spacers if they're all in like the same sizes that you can buy in COTS. We don't actually know that yet because it hasn't been Q&A'd, because the Q&A doesn't open yet, and the rule got announced a couple weeks ago, but we don't actually know. But we think so. Or at least I think so. I'm pretty sure that's how it's going to work. Yeah, there's a whole bunch of other stuff in here. We don't need to go into any of it. It doesn't really matter for the CAD-a-thon. Most of this doesn't. This is the rule about what we can do with CAD and software for the actual robot. Basically, anything we want to reuse needs to be public before kickoff. It's a little bit weird because it only matters if you don't modify it. Which is a little bit odd. One of these examples, where is it? A team decides to use maybe it doesn't exist. They built.
That was example 3.
Yeah, I don't know. The same following kickoff, they use a previously developed tools as a reference for the algorithms got required because they developed new LabVIEW code. So example 3, they're allowed to port things from previous years, but you're not allowed to use the exact file. So it's a little bit odd. So like you could literally like use something from before as long as you modified it in ways and things. For us, it doesn't really matter. All of our stuff is public. We literally like most of our Onshape documents are shared publicly, and all of our GitHub is all public anyway, so it never affects us in software. Rarely do we use CAD year to year anyway, and almost all that's public as well. Or anything we do use is public.
That just matters for teams that are like closed source.
Yeah, so it matters for teams who want to be secret, but we make everything public so it doesn't affect us. These ones don't really matter. Only work during pit hours. You can't like go and take your robot elements to the hotel and like work on it there.
Can you do that? You can do that with code though, right?
Yeah, you're allowed to work on software. Okay. We're not going to go through all the bumper rules because there's a lot of them. At some point, everyone should read the bumper rules. They are helpful. But they do not affect us at the moment. They might when we start talking about gaps, but the main point is you do have to have 6 inches from each corner covered, so you can't have like an entire frame rail open. Most of the time for us, we're going to have a full bumper loop. It ends up being stronger and helps protect your robot frame better, but it's not required. There's a bunch more stuff on mounting and how they're constructed and the noodles and a bunch of things that go into how to make bumpers that there's probably too many details on, but that's fine. Allowable motors, there's a ton of motors that are allowed. Largely, we're only ever going to use Falcons and Rev Neos. I don't foresee us using any other motor unless for some weird reason there's a really specific use case for us to use a Neo 550, then maybe, but even then I doubt we do it. Most of the time we're going to be using Falcons or Neos, and predominantly Falcons for this next year, and we'll start shifting to Neos probably in 2024. That's for 3847. 8515 will run Neos this year, like they did last year. And if they end up needing to use a 775 or something else, they can do that too, like some of the older stuff. But yeah, there's a lot of different things you're allowed to use. There's some specific call-outs. You're allowed to have like hard drive motors and like the motors inside of cameras get called out in here. Yeah, vibration and autofocus motors in COTS computing devices. Otherwise, it got really weird that you weren't allowed to like put a cell phone on the computer on the robot for a while because you couldn't have the rumble motor in there.
Or you had to take out the rumble out of the front.
Yeah, there's like no way to do that. Not easily. Yeah, so a bunch of these are all just like little things that had to get carved out so that other things could be legal. I don't want to talk about fan rules right now because it'll make me mad. So I'm not going to do it. It'll make me angry. Yeah, in general, we can't modify motors, so you can't just like drill into a motor or try to modify it to make it have more power or anything like that. We're not allowed to do anything to the internals of any of the motors we're allowed to use. We're only allowed to power the devices off specific motor controllers, and how to actually do all that, like the circuits for how you're allowed to control the motors and any other output device are all pretty rigidly defined. Yeah, how they're allowed to be controlled together all exist. There's some things we're allowed to control 2 motors off of a single motor controller. They won't affect us anymore because none of the brushless ones work that way, and we're only running brushless motors. Servos, how you can control them, don't matter for what we're doing. Battery specs, there used to only be like a couple brands of battery you were allowed to use, which are basically these two. And then they moved off and let a bunch of the other ones all exist, and pretty much everything that meets the kind of general spec of our battery, which basically means if it looks like an FRC battery and it has the correct amp hour rating, then we're allowed to use it for the most part. There's some very specific things. It does have to have the same like little tabs that our batteries have. There's some other things that go in there. But largely, you're allowed to use batteries that account to be FRC batteries. For us, that means we buy MK ES1712s, as that's the battery that we almost always use. You are allowed to have other batteries if they're built into stuff. So like you can put a GoPro on the robot that has its own battery, and that's fine. You can also use a USB battery pack to like power certain things if you need to. It's a little bit weird. The specs for what these exist and how they exist are a little odd, but there's definitely ones that you can use if we need to. Yeah, some of these are how you charge the batteries all have to be correctly in the same way. We're not allowed to use other batteries as ballast. So if we didn't have a dumbbell around and you wanted to like add 13 pounds to your robot, you can't just put a second battery and strap it to your robot. There was a whole big to-do about this in Orlando one year. It was a giant mess. There was like retroactive DQs. It was a whole very big problem before that rule existed, and then the rule got in the rulebook the next year. Yeah, the battery shouldn't come out if the robot tips over, so you have to have some sort of strap on the battery. All the battery terminals should be insulated. You shouldn't be able to have any connection that isn't at the actual like battery connector. Let's see. So yeah, so then this is the 608 is an important rule, but also a very odd rule. It kind of is here to explicitly disallow a bunch of people from doing like crazy things. The only energy we're allowed to use on the robot is explicitly defined as the battery, compressed air in the pneumatic system, a change in altitude of the robot, right? So we're allowed to start things up high and make them go down low. So you're allowed to have any potential energy that you start the robot with from gravity. Anything storage achieved by deformation of robot parts. So we're allowed to store energy in springs, which is basically what that means, right? So surgical tubing, gas springs, actual compression springs, rotary springs, any sort of bending of something to get stored energy. Yeah, closed loop cuts, gas shocks, the types of things that are on like the back of your tailgate or SUV, what's the rear door? What's it called? No, of like a.
The trunk?
Yeah, like the trunk of an SUV, the hatch, the hatch door of like of an SUV or whatever. And then oddly, the air stored in pneumatic tires is also allowed, which is important because before then you weren't allowed to like inflate pneumatic tires. Technically, like people did it before they realized it was technically against the rules. So then they added it in, so it's not. But anything else is not allowed. What the base of that means is like you can't have anything besides the batteries that are allowed are illegal. Any other way to like chemically make a battery is illegal. You can't like.
So you can't do like a chemical reaction or like have uranium or something.
Correct. Yeah. So nothing radioactive, no chemical reactions, none of that is allowed.
Were people thinking about like putting uranium on a robot?
Probably not, but it's important that we make sure it doesn't happen.
We can be trend breakers, trendsetters.
R608 is very explicit that we can't do it. Well, R608 and the other one that says don't put dangerous things on the robot.
Well, we just make our uranium spring.
Dangerous is subjective.
Yeah, radioactive things are definitely not allowed. Okay, so yeah, so then all this, the rest of this stuff, or a bunch of the rest of this is like the power path. So you have to have the main breaker and power path has to be the same way on every robot. They all look like this. They have to look like this. Nothing can go in between. You can't have other connectors. Like sometimes teams will try to have like a second battery connector somewhere for some reason. I don't entirely know why, but you'll end up trying. You'll see teams with it, or when we do inspection and stuff, we have to rule it illegal. But basically, the battery path has to look exactly like this if you're using the PDH, or like this if you're using the PDP. Yeah, each of the little, the actual power terminals, each only has to have one breaker, and you can't connect the power paths together. So this is how we limit how much power can go to like each motor. They can only have their own breaker. There's a lot of things to just keep everyone in line so that we're using things safely. We're not starting fires on the field. Things like that. Yeah, your robot frame can't be connected to power or ground. That's important so that if two robots touch each other, they're not like having different electrical potentials and causing sparks. That'd be very bad. You have to be able to turn the robot on and off safely, so the power switch has to be mounted in some way that's not going to be covered or right next to spinning gears or anything you wouldn't want to put your hand next to.
So that's why like Photon almost got like one of the inspectors got mad at us with Photon because the power switch was inside the robot.
Yeah, even then it was fine, but yes, inspectors will choose to be more annoyed by certain things than others. That's anytime like that, you elevate it to the LRI, and then they make the actual choice. Yeah, the electrical system must be inspectable, so we have to be able to like view the PDH and stuff. So you can't just have it permanently buried somewhere. So it's allowed to be like covered. So like on our 2022 robot, we had a cover over it that you had to take on and off to be inspected, but that's fine as long as you can get to it in some way. Easily visible, even if you have to remove stuff, it's fine. It doesn't need to be visible during the match or anything. It just has to be visible for inspection. There's some limits to like what the voltages are allowed, so you can't have any voltage on the robot above 24 volts. So there's certain things that need to be boosted above 12 volts from the battery. The radio is that way now, so the radio runs on 18 volts now, which is fine. Some of the solenoids run on 24 volts, but we can't run anything above 24 volts. RoboRio has to be powered the way it's supposed to, which is fine. Radio has to be powered the way it's supposed to off of either the VRM or the radio power module from Rev. We use the Rev for radio power module now. It's better. Let's see what else. Yeah, power radio. Yeah, one wire connects to each of these. You can't have like multiple wires going into any of these lever connectors. That's illegal. Only use the specific circuit breakers that are allowed. That's easy. Specific fuses that are allowed and the little fuse spots that exist. Yeah, so then this is the list of like what size wire and what each thing that's powering what circuit breaker you're allowed to use for it, and then what size wire you have to use for it. We make this pretty easy. We use 12 gauge for anything that needs 12 or 14, and then we use 18 for anything that uses something smaller, and there's some stuff that we use 22 for, that's really tiny. But most of the time we do almost everything in either 12 or 18 gauge because it's the easiest set to use. So all of our motors get powered with 12, and then anything smaller light duty stuff we run 18 for. Let's see, signal level. Yeah, there's some more wiring specific stuff. We don't need to go into the details there. You have to use connectors that are also meet the gauge requirements and current requirements for the motor or for whatever the power path is. This one bites teams a little bit. This is why we use specific color wiring. We can't wire a whole robot with purple wiring or something. That's not allowed. This is so that if someone needs to inspect your robot or look at something, they know which side is ground and which side is positive by just looking at the coloring. So positive is allowed to be red, yellow, white, brown, or black. That's why we use a lot of white for our positive side. Or black with a white stripe, but that would be really confusing, so we don't do that in most places. So most of what we use is white or red for positive, and then we use black for negative almost everywhere. There are some exceptions. Whatever was originally attached to legal devices are fine, and then Ethernet cable can use whatever is needed in the Ethernet cable. What else? Yeah, so we don't modify the critical power paths to the motors and things. We don't add stuff in between the breakers and the motors or anything like that. Robots controlled with a RoboRio, that makes sense. And that keeps everybody standardized. Robot has the same radio that we're allowed to use. We use the Ethernet port for the RoboRio. Oh yeah, use specific Ethernet port. The RoboRio Ethernet port must be connected to the specific bridge port labeled. Yeah, that makes sense. Yeah, and you're allowed to put a network switch between them is what we do now. Some specific networking stuff that all gets in the rules. Everything has to be configured for your own team number. If it's not, you could try to connect and the field would think you're a different team, which would be bad. Don't do that. You have to, anything that's connecting, like communicating between the operator console and the robot has to go through the actual field network. You can't like have your own wireless or something somehow connected. There's no other wireless allowed anyway, which is important. You do have to have the wireless bridge, like the radio has to be visible so that the FTAs can see it on the field in case there's a problem. You have to mount a signal light somewhere that is easily visible while standing 3 feet in front of the robot. However, nowhere else in the whole manual defines front. So the signal light has to be visible 3 feet while standing somewhere 3 feet away from the robot. The signal light has to be visible. That's the only rule. It's very confusing why front is located here. No one understands why that's there because front is not defined anywhere. You're not allowed to modify the control system in other ways, so you can't drill holes in the RoboRio. You can't try to like unsolder and solder different things in the RoboRio. You can't do any of that. You can connect to it like you're supposed to, and that's basically it. Same with like the radio and everything else that's part of the control system. You can't just like modify it to make it better or anything. Let's see. Yeah, I don't even know why this is a rule. I forgot this was a rule. It makes sense. Don't do that. So you can't have motor outputs. Don't connect motor outputs to RoboRio. So like the things that should be powering the motor, you can't just power into the RoboRio. I don't know why you would. It'll break the RoboRio. It doesn't help you. It's a very odd rule because I have no clue why you'd want to do this. All of the PWM controllers have to be controlled by the RoboRio. There's some more specific control system stuff that we don't really need to go over here. CAN motors have to get their heartbeat from the RoboRio, which is all that has to happen. Everything else, they can communicate to each other, they can communicate to other CAN devices, all of that stuff. But the RoboRio has to basically send the enable post or the enable heartbeat so that when we disable the robot, everything actually does disable properly. Let's see. We have to control pneumatics and servo from the RoboRio. That all makes sense. The PDH has to be connected to the CAN bus. This lets us get the log data for like circuit breakers and how much current the robot's using during the match. So that helps with diagnosing problems and things for all the other for every robot on the field. Let's see. Yeah, don't alter CAN bus. You are allowed USB CAN adapters now because of the Canivore that got added last year. But it's the only one currently allowed. We're not going to go through all the pneumatics rules, but basically we're allowed to use pneumatics. All the systems that we've used and we have, like different cylinders, are all allowed. We're allowed one compressor that has to be mounted on the robot to fill air tanks. You're allowed as many air tanks as you want. So we can store a lot of air. We're not allowed to modify them in other ways. You can't just like drill into them or make your own air tank or anything. It has to be an actual like bot pneumatic component. So as long as you are purchasing it, most of the time it is legal as long as it meets all the ratings and things that are required in these rules. They're normally pretty okay. And then they have the sample circuit with what a pneumatic circuit looks like and how to set all that up. Okay, I think that's most. We're not going to go through most of the pneumatic rules. I think we're getting close to the end. Yeah, so we're allowed, operator console rules are very specific, that you have to have a laptop that has like a visible display on it so they can actually see the driver station app running. I don't know why you would not do that, but you do have to. You have to connect to the Ethernet directly. Interesting. Yeah, so you're not allowed to run through a switch. I don't know why you would, but you're not allowed to. Yeah, so there's some specific rules about operator console dimensions. They're a little bit weird because they don't like have a drawing of what any of this means, so it doesn't actually say what deep means or long, which is confusing. It does say they can't extend more than 6'6" above the floor. Yeah, I do feel like this rule probably needs to be updated at some point because it really isn't clear what this means. Like, so I guess some dimension has to not be greater than 5 feet, and some potentially other dimension has to not be greater than 1 foot 2 inches. But it doesn't really say that these are different dimensions. They probably are. Yeah, you can only use the field wireless. That's all normal. I think that's most everything. Okay, so yeah, so that's the entirety of the robot rules. Most of those, like I said, almost all the electrical and stuff stays the same. They're all in green rules. So learning them now means we know what they are for next season. We don't have to worry about too many updates to them. We kind of are. There's a blog post with what the updates are, and there's not many. So again, most of the robot rules largely stay the same, other than potentially things like frame perimeter, like starting configuration. So what the max height a lot of times will change. So like maybe it's going to be 5 foot next year, or 4.5 feet or something instead of 4.4. Extension normally changes a good amount. Most of the other stuff all stays the same. So those are going to be where we're at every year.